Suppose that we are engaged in a stock selection exercise, and we're doing, to keep it simple, univariate sorts based upon a number of firm-specific characteristics. So, suppose it's the case that we identify 3 characteristics that appear to be important. First characteristic is book to price, kind of a value indicator. The second characteristic is expected earnings growth. And the third characteristic is just past momentum in stock returns. And we do our analysis and we find that each of these characteristics produces a large spread between the top portfolio and the bottom portfolio. The question is, how do we use that information to develop a strategy for investment? How do we use that online? Well, there's many different ways that we can approach this. And I'm going to suggest a simple way and a more complex way. The simple way is somewhat ad hoc, but go along with me to see what you think. What I'm going to do is assign a score to each stock based upon a characteristic. For example, I'm looking at book to price as my value attribute. And each month I sort by book to price. And the low book to price stocks are my value stocks. And suppose I have 3 portfolios every single month. Suppose I have 300 securities, there's 100 securities in each portfolio. And I've seen the book to price actually is able to separate high expected returns from low expected returns. So the buy portfolio does much better than the market as a whole, and the sell portfolio does much worse. Suppose I go through and assign a score. So if you're in the buy portfolio, you get a numerical number of 3. If you're in the middle portfolio, you get a numerical number of 0. And if you're in the bottom portfolio, the sell portfolio, then you get a score of -3. And then we can move on to our other 2 attributes. So if we're standing, let's say, at the end of February, we know the book to market ratios for 300 firms. We can assign these ratings for each firm for book to market. Now I'm going to do the same thing for the next attribute. Anything that's in the buy portfolio, assign it a 3. In the middle, assign it a 0. And in the bottom, assign it a -3. And then we can move to our last attribute, price momentum. Again, the same situation. Any stock that ends up in the top portfolio, assign it a 3. If it's in the middle portfolio, a 0. The bottom portfolio, -3. So you can think of a spreadsheet. February spreadsheet, at the end of February, we've got 300 firms, 300 rows in that spreadsheet. And there are 3 columns. We've got 3 attributes. And every single stock is scored for each of those 3 attributes. Stock number 1 might fall into the top portfolio for book to price, it gets a 3. The second attribute, maybe it falls in the middle, it gets a 0. The third attribute, price momentum, maybe it falls in the top portfolio, it gets another 3. Total score, 6. Stock number 2 maybe falls in the bottom portfolio for all 3 attributes. It gets -3, -3, -3. Total score, -9. Stock number 3 perhaps falls in the top portfolio for all the attributes. 3, 3, and 3, it gets a +9. We go through our list and we've got a summary score for every single stock. Sort by that final score. The maximum possible number you can get is a 9, and the smallest possible number you can get is a -9. invest in the 100 securities with the highest scores. Hold that for March. At the end of March, the new data comes in, resort based upon those 3 attributes, assign scores again, and form a new portfolio that you're going to hold for April. This is what I call a scoring screen. Now, I said there was 2 ways to do this, and this way is rather ad hoc, because in a way what I've done is I've equally weighted both the buy and sell portfolio as well as the all of the characteristics. Everything has a score in the range of 3 to -3. And indeed, we could make some adjustments. So suppose the first 2 attributes were very good, very impressive in identifying high and low expected returns. But the 3rd attribute wasn't quite as impressive. It had a lower spread between the high and the low. So conceivably what we could do is for the first 2 attributes, we have a system going between 3 and -3. In the last attribute, we could have a system going between 1 and -1. And that effectively would change the weights to which we place our scores on these attributes. So this is a practical way that we could actually implement a methodology, a so-called scoring screen, to get a final portfolio of stocks that we would buy and stocks that we would sell. Remember, when I say the buy portfolio for price to book, that is only a buy portfolio if it's the only attribute that we would ever look at, and that's extremely unlikely. Now, there's other ways to do this. We've got 3 characteristics, and we've got a portfolio that is our so-called buy portfolio for each attribute, and we've got a portfolio that's a sell portfolio for each attribute. So you have a total of 6 portfolios. And historically, we have returns, and perhaps we've got 10 years of returns, 120 observations for the 3 buy portfolios, for the 3 sell portfolios. And the question is, how do we weight optimally the information in these attributes to get the highest possible return? Well, this is just an issue of optimization. Put those 6 returns in a mean variance optimizer, put no short sell constraints on the problem, and let the optimizer pick the weights. And indeed, I say you want no short sell constraints because for some of the characteristics, we'll put a negative weight on them. Just like we put a -3 on the sell portfolio for price to book. So the optimizer, and actually you would want to put some constraints on it so it doesn't put wild weights like minus 1,000,000%. Probably want to put some range of constraints. And the optimizer would work and figure out what the optimal weighting scheme is. And here you would have likely a differential weighting scheme between the buy and the sell portfolios. And you would likely have differential weights between the different characteristics. This method looks at not just the performance, but the volatilities and the correlations between portfolios built upon these characteristics. So there's a simple way to do this. There's a more complicated way to do this. But in the end, we get a scoring screen. And this is actually how to implement a stock selection methodology.